So welcome to introducing the 6th edition of Chemistry in the Community. This is a part of our American Chemical Society ChemCom webinar series. My name is Michael Murray, and I'm with the American Chemical Society here in Washington, D.C. And I have with me Master Teacher Steve Long from Rogers High School in Arkansas. Steve was also the chair of our editorial advisory board for the 6th edition of this text. So as we go through, one of the things, if you have a question, put your question in the chat box, and then what I will do is paste it so everybody can see it, and then we will, either Steve or myself will answer those. Please participate, and please have fun. We're excited to have you here tonight. So our goals for this webinar are that you will become familiar with all of the new features in the 6th edition of ChemCom, and we want to share with you how ChemCom meets the needs of the 21st century student and the 21st century teacher, and how it meets with the latest research in chemical education, as well as education in general, and with the important topics in chemistry. And then we want to share with you some of the activities from our first unit that we've added to. This is the first time we've ever had a Unit 0 in any of our editions of the text, and so we want to share that with you as well. So the first thing I want to do is launch a poll, and if you will answer which edition of the text you are using, that I would appreciate that. If you have, if you're not using the text, click that as well. So you can go ahead and answer. Okay, so let me close that. And the results were, I don't know, you should see the results that both of our participants are using the 4th edition. So there are huge changes between the 4th and the 6th edition. There were minor changes between the 4th and the 5th edition, and we will make sure to point some of those out. So that's good for us to know that you both are using the 4th edition of the textbook. You will see some major differences in the 6th edition, some that we're really, really excited about. So the next question that I have for you is, have you, give me 1 second. Oops. Steve, do you still have the PowerPoint up?
I do.
Okay. For some reason, I can't get the other polls to show up. Oh, okay. So here's the next poll. Have you ever looked at the 6th edition of Chemistry in Content, of Chemistry in the Community? Okay, so half have looked at the book and half have not looked at the book. So that gives us some great feedback as well. So if you have looked at the textbook, you definitely will see that it is way different. If you have not looked at the textbook, after this webinar, please send me an email, and I will have one sent to you so that you can see it. We will show you several of the pages, but I definitely want you to have the opportunity to see the textbook as well. Okay, so our third question is, are you familiar with BSCS? And so I'm going to launch that poll right now. Okay, 50% and 50. So half are familiar, half are not. So as we go through talking about why we went about some of the changes that we did with the textbook, we'll talk about that. BSCS is the organization that we use to actually do an analysis of our textbook in order to give us some feedback to make the textbook even better. And finally, have you heard of Understanding by Design or Backwards Planning UBD? Okay. So half have looked at that, half have not. Great to know. UBD is some of the way that we have the unit structured in ChemCom actually follow UBD. So we will talk about that as well. So thank you very much for your participation. And we will continue. In the question box, if you will tell us where you're coming from so we know where in the country we're looking for. New Jersey and Arkansas. So great. That's who we have with us tonight. And Sherry, I did see your question, or I did see your comment about piloting the 6th edition. So if you have any questions about that, please let us know throughout as well. So our agenda, we're going to look at, before the textbook, the 6th edition was released, we had our editorial advisory board come up with some standards of identity, and these are pieces that will guide the ChemCom philosophy. So what do we always want, no matter what happens to the textbook, what pieces do we always want to come through? And Steve is going to talk to you about those. And then he's also going to talk to you about what are the influences on this new edition and what went into making that, as well as the goals. Then we'll step through what all the new features are, and then we'll look at Unit 0. And then we'll talk a little bit about correlation to frameworks, and then talk about a little bit about future professional development. So I'm going to switch it over to Steve. Again, yeah. Steve is coming to you from Rogers, Arkansas. He is one of our definite master teachers of ChemCom, and he's been teaching ChemCom for many years and has been a teacher leader doing workshops for us for many years as well. And he's amazing, so I will switch it over to Steve right now.
You're very kind, Michael. Thank you. If you would pull the PowerPoint back up, we're still looking at the poll.
Oh, shoot. Thank you.
So they might want to see that agenda that you have set there. I know you talked through it, but... Well, it's nice to have people from across the country and a kindred statesman from Arkansas on. That's nice to know.
Okay. I am... Give me 1 second. I have lost all the polls.
I'll tell you a little bit about myself while Michael is pulling up the polls there. I mean, pulling the poll down and putting up the PowerPoint slide. This is my 38th year of teaching. I've taught chemistry for all but one of those years, and I've been involved with ChemCom since about 1992 in some form or other, either as a teacher or a participant or something along the line on that. The school that I teach in Arkansas is a relatively large school. We have about 2,000 students in our high school, and they're about the same number in our sister school across the other side of the city. We have about a 40% Hispanic population, about a 5 to 8% population of American Indian, African American, Asian Pacific, and so we're roughly 50% Caucasian and about 50% other. And so our school probably looks like many of your schools across the country in many aspects on that. I was asked to chair the editorial advisory board for the revision of the ChemCom 6th edition, and that was quite a weighty responsibility. There were a number of people on that team who were previously involved with chemistry in the community, and some of them going back to the very beginning of that, as well as former writers, and we had some veteran teachers, some of the other master ChemCom teachers on there, as well as some newer people. And the thing that we tried to do, as Michael alluded to a moment ago, we tried to look at what are the immutable things that make ChemCom a unique textbook. And so we had many hours of discussion by phone and other processes so that we could kind of come through with that process. And we came up a list of bullets of things that we thought made ChemCom unique in the textbook world. And so that's what we're going to take a moment to go over now. These standards of identity, as your slide now shows you, was used by the authoring team to make sure that they held true to those things that were important in ChemCom, and yet had the flexibility to change those things, which would help it to modernize and would allow it then to be fresh. As we went through it, we like to say that the 6th edition is not your mama's ChemCom textbook, because while the program had been around for a number of years and it had gone through a number of revisions, we felt that there were things that we could do to refreshen it. And so those were the things that we wanted to look at. So Michael, if you go to the next slide, then we'll take a look at what some of those bullets were. We believe that the most important features of ChemCom, those standards of identity, those hallmarks that should not change, was that it would be consistent with the National Science Education Standards. And of course, when this work was being done a couple of years ago, even though we knew that next generation science standards were under development, nobody knew what they would look like or anything about that process, so we held to the only standard that we have, which was NSES at that time. We believed that it was important that we introduce chemistry concepts in the course and then come back to those and elaborate and spiral through those on a need-to-know basis. So when we teach a concept in the ChemCom textbook, such as pH, we might introduce the concept of pH, but we don't necessarily teach everything about pH at that point. We teach what you need to know to understand the chemistry that's taking place at that point, and then as we develop content and storylines through the book, we come back and visit pH a number of times so that we deepen that understanding to the level that students need. And that's what keeps ChemCom fresh, is that rather than teaching kids everything about a concept, you teach them what they need to know, when they need to know it, and they don't feel overburdened with that process. It also involves text-embedded activities, including the lab investigations, which we call investigating matter. We know that sometimes teachers get pressed for time, and there's a tendency to jump over the labs so that you can cover the content, and yet when the labs are embedded in the textbook, after a while the students will begin to hold the teacher accountable. And they'll say, "Teacher, why didn't we do this lab that's right here? This looks really cool." And so the labs are not only there for the teacher and for the student, but we actually develop a lot of very important science through those laboratory investigations. And so rather than just being kind of a confirmation activity, the labs also teach content, and so they are important that we include them and that they are done. One of the main aims of ChemCom is to introduce chemistry literate and science literate citizens. So we want to focus on things that will make good citizens for life. Not all of our students are going to go on to be engineers or doctors or chemists or anything of that type, and yet we know that all of our students are going to be faced with voting and understanding challenges, such as environmental challenges or nuclear challenges. So we believe that it's important that they know what the truth is and that they understand some basic science so that they can make intelligent decisions. The ChemCom book, we also feel, needed to focus on the use and application of the knowledge and skills, not just on their development. So how do you use it? It's not just enough to know it, but then where do you apply it? Why is it important to know that? We felt that another standard was that this is a general chemistry class for all college-bound students. There are sometimes that people that say, well, you know, college-bound students don't need to know these things, or college-bound students need to know more than that. That's all based upon your state and your district curricula and the frameworks that you have there. But this is a foundational course that is appropriate for all college-bound students, and it is approved by NCAA and for those other processes to go through for all of the criteria that go into the athletics and things. So people often ask us that question. One of the most important things that we do in the ChemCom textbook is that we look at decision-making skills. And students tell us that the decision-making skills are some of the most interesting and some of the most difficult of the activities in the book. Because as many of you know, it's when you're making a decision, you're faced with a set of criteria or a unique situation. There may not be a single right answer. There could be a multitude of answers, all of which could be right in some aspect or in some way, and so students have to practice those decision-making skills. Another issue is that, of course, that we look at technological and societal relevance. So you will find in the textbook that we often link to things like of geological or environmental or water issues. There's a whole unit on nuclear because we know that that's important, and those are things that people need to kind of work through and to understand better. And so those are some of the processes. And as we move on to the next slide, and this is our last slide of standards of identity, but we want to take a look at long-term development of problem solving and concepts. So once again, this is a process where you keep building throughout the unit and throughout the entire textbook, so that we have long-term types of deals. We learn a skill, we come back to it again, and we make sure that those problems and the concepts are developed over a long period of time. Just as in professional development, we found out that a one-day workshop really doesn't change teachers' attitudes a lot, so we don't necessarily want to have one-day lessons for students. We want something that will take days, weeks, or months for them to develop and to keep coming back to. We need to help students to understand chemistry concepts at the submicroscopic level, as well as at a macroscopic level, and then as well as a visual level. So for example, the pictures in the mind activities that are in the textbook, and Michael will talk about those in a moment, but they help students to take a look at what does gas look like at the submicroscopic level. If you could see gas particles, what would they look like? And then how would you draw a picture of that? And then what does that do as we look at the effects of gas or gas pressure on objects that we can see with the naked eye? Those are challenging activities, but that's where we really get to the heart of students understanding chemistry. We also initiate each unit with some type of a chemistry-related issue or challenge. Then we have a unit-long storyline that helps the students to kind of stay focused on what we're trying to learn. We call it a golden grabber. It gives them a reason to want to dig in and to learn the material and to stay focused on all of the content that will be used in there. And then we come back to that activity at the end, and there are a variety of activities that we use in various forms, writing projects, multimedia, skits and plays, that will allow the students to demonstrate that they understand what they have been learning and that they can make it unique and personal for them. And that's done through the putting it all together activities that Michael will discuss in a few moments. The chemistry content is congruent with a 5E model. Although we didn't write it as a 5E instructional model, you will find that there are those components and pieces that are just embedded in it because 5E is good instruction, and the ChemCom textbook uses very good research-based instruction in it. In addition to the inorganic chemistry that most introductory high school textbooks will have, we know that the vast majority of chemistry in our life is at the organic and the biochemistry level, and so we wanted to make sure that those topics were represented, as well as the environmental and the earth science topics that students see and relate to as often. The United States is one of the few countries that really focuses merely on an inorganic approach to introductory chemistry. If you look at most of the countries in the world, they will have a strong emphasis on biochemistry and organic in their introductory classes, and so ChemCom follows a world lead on that. And last but not least, the ChemCom Standards of Identity want to emphasize the complexity of chemistry-related societal issues. There really are no single issues. So you see a toxic spill, you have an oil release that's taking place, you have the need for a new material that has new properties. It is not easy to just develop something that doesn't have ripple effects down the line somewhere else. So we want students to understand that if there were simple solutions, they would be simple to come by. Instead, the world we live in is complex. Parts are all interrelated, and sometimes those solutions are much more complex than what you would ever dream. And so those are the things that we told the editors and the writers that they needed to hold true to, and then they were free to kind of improvise and to improve on other areas of that. Some of the important influences that were used in the 6th edition was the BSCS AIM process. BSCS is a curriculum organization located in Colorado, was originally called the Biological Sciences Curriculum Study Group, and they developed a number of textbooks way back in the day. And they have a process called Analyzing Instructional Materials. And we submitted the 5th edition of the ChemCom textbook to BSCS so that they could literally tear it apart and analyze every aspect of it. They looked at what were the students doing, what was the level of engagement, what was the level of questioning that was taking place, what were students doing, what was the teacher support material, and they analyzed it in so many different aspects, and they gave us very valuable feedback that was used then to help put the 6th edition onto better footing and to make it, shall I say, more coherent in its approach. As was mentioned earlier also, we used an understanding by design, and that was a process that was first put out by McTye and Wiggins, in which they said you should always start with the end in sight. So if you know that you want students to be able to do X at the end of this unit of study, then start at X and work your way back through the curriculum until you find out what are the activities, what are the content, what amount of time would it take in order for them to be able to get to that. Curriculum planning for so many years was actually you start at the beginning and you kind of work your way to the end, and when you get at the end you assess what you've done and you hope that you covered it. But the McTye and Wiggins process says no, you start at the end and you purposefully work backwards. And I think you see that in our putting it all together activities, where we know that we want students to be able to perform a certain skill or task. So to do that, what content do they need? What kind of hands-on activities do they need? What kind of decision-making activities do they need? What kind of skills and practice? And we develop all of that into place to make that happen. There was also an important book on how people learn, which was published by the National Academies of Science, the National Academies Press. And this book took a look at the brain research. How do people learn? What do we know about the brain and the processes? And so this type of research was very important in terms of helping to develop the activities and focus on what we needed to do. If you're familiar with the science writing heuristic, was a process that was developed by Carolyn Keyes and others in about 1999-2000. And the science writing heuristic has been used in the ChemCom textbook in a modified way, particularly in our investigating matters, where instead of students stating a hypothesis, they make a claim, they support it with evidence, then they go back and do writing and things on that process. So again, a very structured approach into the laboratory activities, and a strong improvement over what we've seen in the previous editions, and a strong improvement over what is done in many other textbooks and processes. In addition, we always use teacher feedback. The ChemCom textbook is unique in that it was written by high school teachers, for high school teachers, with influences of others who were used in that process, but from the very beginning, teachers had a strong voice and a strong part in this, and so we took feedback from teachers who were using the book, as well as from those who had analyzed it, and those were all important in helping to design what we did in the 6th edition. And I must say that the writing team did a wonderful job of pulling all of those pieces together and making a really nice program out of that. There's a key goal in the book, and that's to make interactions with the phenomena a central aspect. One of the ways that we do that is each unit begins off with some common experiences. It's typically a lab called an investigating matter. Oftentimes it has stations where you will have multiple activities that are set out, and students go and they collect information about some phenomena that they're going to study, whether it's air or nuclear or water or whatever the case might be. And then from that shared common experience, then we can begin to develop the content that they need to understand what's going on. We are very purposeful in modeling the scientific ways of knowing, so that we look at the habits and the skills of the mind. And that again comes from the brain research to make sure that what we're doing is appropriate for adolescent learners. There was a very purposeful reorganization of the units that were put in place. Both of you, I believe, on the webinar are using the 4th edition, and of course you know that the 4th edition started off with the water unit, and then you went on through the others through the process. But we had feedback from a number of people who said that the fish kill scenario that was the end of the water unit did not allow students to have great enough science and content knowledge to do more than just mimic playing scientists. So what we did is we took a look at, let's move the water unit later into the course of study, let's build more skills, let's build more content, and then when they do the water unit, then they're going to have the chemistry that they need to know to be able to be a chemist as well as just act like one. And another key feature is, as Michael will point out here in just a few minutes, is the addition of the first time of a Unit 0. The Unit 0 is a little bit of an optional unit, but it does many of the things that most of us have to do at the beginning of the year. It talks about safety, talks about lab skills and activities that will be going on. It takes a look at kind of bonding your class together, doing some common team building activities through science content material, so that if you're doing those things, that we were just able to incorporate those into the textbook. We believe it makes the book stronger, although we know that there are schools who say that doesn't really fit my curriculum. So once again, you're the master teacher. You have to decide where you go with your curriculum, and so whether the Unit 0 fits or it doesn't fit, but we think it's a strong piece, and it's the first time we've put it in a book, so we're really proud of that. Another key goal is to emphasize the scientific inquiry that's taking place, and that scientific inquiry is to provide for the inquiry skills that are in there. We had inquiry skills in editions 4 and 5, but sometimes they hit a very high level of inquiry fairly on in the textbook. And so what we've done is we've purposely scaffolded so that students start at a relatively low-level inquiry, and then they develop that through labs throughout the entire unit and throughout the entire book, so that they understand what inquiry is and what's taking place. And I'll put in a little side note here. I know that the word inquiry does not really appear in the next generation science standards, but it's still about those science practices. It's still about doing hands-on science and making those kinds of investigations that we know that students enjoy doing and need to do. The investigating matters were totally restructured. They have entirely new subheadings. There are many, many different labs. Some of the existing labs and units in the 4th edition and 5th edition have been tossed out. New ones have been brought in after field testing and working through them, and all of that in an effort to provide a better lab experience and to be more purposeful, once again, with the learning that was going on. The inquiry skills that students learn then are used at this end of unit putting it all together project. And so once again, you know, the students learn how to make and refine claims, how to construct a valid scientific explanation or a scientific argument as opposed to playing emotional, and how to take a look at the solutions. Are the solutions appropriate? Do they solve what we expect them to do? So students are using a variety of Bloom's taxonomy here, from identifying and knowledge on up through evaluation processes, and I know that that's something that's important for all of us, and our schools are looking at those higher thinking skills. The last key goal that we'll take a look at is to enhance the student's construction of understanding. We know that adolescent learners learn in certain ways, and there are certain processes that work well for them. So the 6th edition has been created to create a flow that allows this learning to build upon itself. We've taken a look at what we now know in the last 10, 15 years that we didn't know previously about learning theory and cognitive science. There's so much research that's out there, and we tried to incorporate as much as we could in here. Again, we've added Unit 0, and we've restructured those units so that we believe that it's a better fit. The section questions that you would find at the end of each unit have been refocused to more closely align to the goals that we have in the student textbook, and so that you can see a direct correlation between those questions and the goals for each unit. They have been reorganized, and a new feature in the book is the concept check. And these concept checks have been put into place so that students can stop and reflect on what they've learned in the past as they look back, as well as what do they know about what's coming up in the future. And again, research says that if we revisit things in the past, it keeps it fresh, and it helps students to keep learning that, as well as allowing students to look ahead at the future. What do we know about something? You know, if we're going into the nuclear unit, we might ask them a question. What do you know about radiation? And perhaps they know something and perhaps they don't, but it allows them to access prior knowledge, and that's a good way to be able to build interest as well as to make the learning meaningful for the student. The making decision activities that are in the textbook have been redesigned to make sure that they all provide support, and they help develop student skills to be able to be successful on the putting it all together at the end of the unit. One of the BSCS recommendations was that many times the activities that were in our textbook didn't necessarily help to point students to the skills that were necessary to do the putting it all together. And so those have been restructured and designed so that they all flow, and each activity then allows students to gain skills and knowledge that will allow them to be successful on that PIAT. There are sample problems that we've put in there, and in addition, we've enhanced the modeling matter activities. And I'll just say a word about the modeling matter activities. They are some of the most important of the skills, the features in the textbook, but they are the activities that my students love to hate because they are quite challenging, and it requires them to think. This is oftentimes where we go from the submicroscopic to the symbolic to the macroscopic, and it stretches their brain, but I believe that's where we get some of our best learning, and where students really do help to comprehend the chemistry that we're trying to teach them in that process. So I think that's my part of the beginning of the session here, and I'm going to turn the program back over to Michael for a few moments, and I'll take a break.
Okay, thank you, Steve. So now I want us to look at some of the key features in the text. So we're going to look at mainly some things in Unit 1 right now, so that you can see the way that each of the units is structured. Unit 0 is structured slightly different, so we're not going to focus totally on that. But we'll do some Unit 0 activities after we go through these key features. These are also, if you have a teacher's edition of the textbook, these are pointed out in the preface pages for the teacher in that in the teacher's edition. So as you see, the front page, each front page opens on a spread with some beautiful artwork, some beautiful photographs. Unit 1 is this mine. Unit 2 has a beautiful picture of the sky with different colors. It is our air unit. Unit 3 is petroleum, so there's an oil well. Unit 4 is like a waterfall for water. Unit 5 is industry. Unit 6 we have an atom accelerator, which is the most awesome picture. It's amazing. So all of these open on these really cool spreads, and you can have a discussion with your students about why is this picture there. to describe the unit. I think those pictures are extremely thought-provoking and extremely conversational starters. But also on the opening page, you will have the questions that drive each section. So in red on each one, each section has an overarching question to guide it. So in Unit 1, Section A, so how do chemists describe matter? And then we also put it in a statement term, building blocks of chemistry. So kind of like you have essential questions, enduring understandings, we always put something in a question form and always something in a statement form. And these questions are going to, as you'll see in a little bit, they will actually drive the entire section. And then students will actually revisit that exact same question when they are finished with the section. So they really are this little nice bow to tie up each of the sections. So those are always pointed out, the sections and the topics that you're going to learn. And a lot of these topics have more than just what they say. So building blocks of chemistry has a lot more than just pieces of matter. There's some chemical and physical change in there. There's percent composition and things like that. So each section is pretty broad. Having a textbook with only 7 units, each section does have a lot of content. So that's there as well. And then we always have this teaser question. It's a question for the students to think about before they actually enter the unit. So in Chapter 1, one of the things the students are going to be presented with at the beginning is that the U.S. is going to start using dollar coins instead of dollar bills. Do you think this is a good decision? Or what is better, the dollar bill or the dollar coin? And students are going to make this decision. There is no easy answer for this, but they're going to think about this throughout the entire section. And it's one of the ways that students are always have something that they're working towards in these chapters, so, or these units. So there's not always like the random order of a chapter, or we're learning this topic. They always have a reason to learn the topics that they're learning. So each chapter starts with an activity. So it tells them what they're going to be working towards, and that's the part of pieces of understanding by design. So they're going to, the beginning is going to present the problem to them, and the end is when they're going to put it all together. We call that PIAT for short, P-I-A-T, putting it all together, and that is going to be what they're actually going to, when they're actually going to solve the problem. So again, in Unit 1, it is the greener than greenbacks. They're going to try to figure out, is a dollar coin or a dollar bill better? And this is where we always present them a real-world issue that they're going to have to solve, and they're going to have to make this informed decision based on the chemistry that they learn in these units. So the putting it all together piece is when they're actually going to tie this unit up in a little bow and use all of the tools that they have gained in the unit and put together a great response to a question. It's one of the pieces, and Steve likes to point this out, where we put a lot of literacy in the textbook. So these putting it all together, along with several other activities, have the student practice communication skills. So in some cases, they're going to write articles. Some cases, they're going to write a little report. Sometimes they're going to write an editorial. Sometimes they're going to write a persuasive piece. And then other times they're going to do presentations. So this, they're going to make a case, and then they're going to do a presentation as well.
So Michael, let me just jump in there, because I know that many of our teachers are having to look at the Common Core state standards, and there are 19 components of that deal with writing and with reading. And the PIAT, as Michael has said, they can reinforce a lot of those in terms of using technology and the writing and the persuasiveness that you have to do and analyzing different viewpoints. So while the textbook wasn't developed to meet Common Core standards, it's just good teaching, and I think it does that in a very good way. And I apologize for interrupting on that, but I think that is just so powerful, and I think teachers really need to understand how important the putting it all together are and how much they can help them meet those Common Core standards.
Oh, thank you for jumping in, Steve. Okay, so also within the chapter we have, as I pointed out, you start with a question. We'll look at that in just a moment, but you have these learning goals. This is new to the 6th edition. We have not had that in any of the previous editions. We've had learning goals, and they've been used to guide the chapters, but we haven't necessarily, or sections, and we haven't had those available for students to look at. So we have made them fully apparent for the students to see, as well as the teacher. So we put the goals right at the beginning of each section. By the end of this section, these are the things that you're going to be able to do. What are the things that we want you to know and understand? And the really cool thing is when they go and answer questions in the back at the end of the section, you can see these questions. They're red questions in a little box. Those are the goals restated in a different format, but they are all of the goals, and then the questions that deal with those goals are attached right in the back. And that is called our reviewing the concepts piece of the section questions, the section summary. We also have, as I pointed out, here is the section question, like how can the periodic table be used to help explain and predict the properties of chemical elements, and that's what the students are working for. At the end of the section, in the questions, they have this beige box with a green little border, and it is the exact same question, and it's going to say, tell the students, you learned about this stuff, now let's answer this question, and it gives them little taglines. Be sure to include these pieces in your explanation so they can write like a little essay or a reflection on whether they actually learned what was in the chapter and whether they can actually answer this question that was in that particular section. As Steve mentioned earlier, we have implemented concept checks throughout the chapter. The first 1 or 2 questions, usually on a concept check, will have backward-thinking questions, and then the last 1 or 2 will have forward-thinking questions. So the students, you're going to check the understanding of what the students have learned, and then check their prior knowledge as well before they start a section. So those questions are placed strategically throughout each of the sections so that students have like little benchmarks as they're going through, or little guideposts as they're going through the sections. Connecting the concepts is the second part of the summary, and those are where students start to connect and synthesize ideas. So if you're familiar with Bloom's taxonomy, the reviewing the concepts questions that have the little boxes, those are more your bottom level of Bloom's taxonomy. These connecting the concepts are kind of your middle range of Bloom's taxonomy, and then extending the concepts would be your upper portion of Bloom's taxonomy. They're more in-depth exploration. So you can actually definitely differentiate with your students as you're going through the questions. There's students that need more practice. There's more questions for them to answer, and then students that you want to push and maybe push the way they're thinking, you can give them connecting the concepts and extending the concepts. I know that from all the teachers that I've talked to that are using the 6th edition, nobody assigns all the questions in the chapter or the section. They tend to give a couple of questions each night following the sections that they're learning, so that the students get through the questions, but they're not bombarded with a whole lot of questions by the end. So I wanted to point that out. Some other key features, we have the investigating matters. All of our investigating matters are in this like fuchsia blue or purplish color. And those are all of the labs. So there's, I think there's over 35 investigations included in the textbook. And they build on the story, and they build on the progression of the chapter. So they're integrated in. You don't have to go think, oh, what kind of lab can we do? These are all integrated in. And they each have these new section titles. So we always start each section, instead of saying what is the purpose of the lab or background, we always say prepare to investigate. So a real scientist is, before they do an experiment, they're going to prepare to investigate. So we want the students to think like scientists, and they're going to prepare to investigate as well. One of my favorite activities is a chem quandary. These are little puzzling chemistry questions that students can think about. There's usually never a right or a wrong answer. So many of the teachers that I've talked to have used these activities and had their students answer the questions, and definitely pick the students that maybe don't have as much confidence, because a lot of times they have a great answer to share, and this can build those students' confidence because there's no right or wrong answer. Like in Unit 4, in the water unit, there's one, where does all the water in orange juice come from? Like, think about the process of producing a plastic bottle of orange juice. Where does all the water come from? And I've watched students do this, and they love that kind of activity. If you get them, you can even get them like whiteboards, the miniature whiteboards where you can get some shower board at like Home Depot or Lowe's, and they'll cut it for you, and you can use that in your classroom. Or I used in my classroom the little plastic sleeves, and I bought some stiff cardstock and put it in there, and my students love to write their answers there and then share with the rest of the class. So chem quandaries are a great little puzzling activity. They don't take a lot of time, but they can be so useful for your class dynamic and for getting your students to think. We also have several illustrations that were done by Scientific American for the textbook, and those are throughout. They're meant to illustrate some of the concepts. As we know, chemistry is extremely difficult for students to picture. They can't see it. So being able to have some of these illustrations as they build these models in their brain is very useful for them. And then we also have developing skills and making decisions. Steve also mentioned these. So developing skills are kind of typical of your typical homework type problems of practicing, like balancing or calculating the number of moles, or activities such as that. However, in most cases, we make them very real world applicable, so that if you're saying, what forms when you put silver and chlorine together, what is the formula? We'll give them a little bit of background where silver chloride would actually be used, so they actually have those. So that's important for us to have in there. And then the making decisions, as Steve mentioned, they build on having the students be able to solve that, putting it all together, that major activity. So the students build little, they build their resources as they're going through the making decisions. One of the things about the making decisions that I've heard from some teachers is they have their students do making decisions in their groups. They usually have their students do the activities in little groups, and then they save all the making decisions until the end of the unit, and then after they get, when they're preparing to do their final activity, they provide those back to the students so that they can use those in their, for their final activity. Some other key features, my absolute favorite thing in this textbook is the modeling matter. I'm a computational chemist by training, and I actually love anytime you can model stuff. So they are so exciting. These activities, and as Steve said, they are activities students love to hate because they're not easy for them, because they have to come up with these ideas. But when you get to see a light bulb come off on a student when they actually understand one of these activities and they can go through, it is so exciting. And it's so exciting to see what they come up with, because you then actually understand whether they are understanding the concept or they're just plugging and chugging through things. If you teach them how sugar and salt dissolve, and then you have them draw that, and you see them pulling the carbon and the hydrogen and the oxygen off of sugar and dissolving, and then you know they didn't really understand that concept. So it's very, very useful. And one of my favorite ones is in the air unit, and the students are learning about the properties of gases and kinetic molecular theory, and it actually gives them, they get a shoebox, and they have bouncy balls in the shoebox. And you talk about the bouncy balls are the molecules of the gas, and you can make it go faster. And if you made the shoebox smaller, what would happen? And so they can actually predict those things based on those bouncy balls. And if you buy the clear containers that are about the size of a shoebox and buy some bouncy balls, you may have a loud classroom, but the students can actually play with that. And I think they really, really, really like that. We redid chemistry at work. I know in many standards it's mentioned that you have to talk about what real scientists and chemists do. And in previous editions of ChemCom, we've had these, but they've been really like write-ups for students to actually read, and just like an essay kind of thing. So what we did for this edition is we made them all Q&A, and we've tried to pick scientists and chemistry that students would actually be interested in. So in the first unit, it's on fireworks, and they asked Dr. Conkling about how he does fireworks. And one teacher came up to me one time, and she said she was teaching, and she watched, and some of her students were peeking and trying to read about the chemistry at work when they saw the fireworks. And she said that had never happened, that they would read something like that before. But they found it so interesting and such in a readable style for them that they could read through it, and it was actually something pretty interesting. And that just made me smile, because I know when I was teaching, my students never wanted to read that kind of stuff. They didn't want to read the textbook at all anyway. So for them to actually try to sneak and read, that was pretty cool. So I really like to hear those types of stories. Okay, we're going to walk through Unit 0 pretty quickly, just so you can see what students are doing. The reason we implemented Unit 0, as Steve mentioned, was that a lot of times that first week of school is kind of chaotic. You might have students coming in and out of classes, schedules might be changing, you might have assemblies. I know when I was teaching the whole first week of school, like we had 3 different assemblies on 3 different days, so it really affected what you could get done in teaching. So we added this because, first, I don't think many students have experienced a textbook kind of like ChemCom before. A lot of teachers haven't experienced that. And we wanted students to know and understand how they're actually going to be learning. And then, why is it called chemistry in the community? What is chemistry? What is a community? And then the safety pieces. I know most people have to teach their students about safety. We added that in there into the chapter, our Unit 0. And then we actually show students how ChemCom is structured so they actually can understand as they're going through, oh, this is a developing skills, oh, this is investigating matter, this is what they're for, and this is how it's helping me become a better citizen. I think every time we talk to students, it's about we're becoming better. We're teaching you to actually understand chemistry and science so that you become a better citizen. we're not expecting that all of you are going to become chemists, but we want you to actually understand the chemistry so that you can be a more productive citizen. So in Section A, they talk about the central science, what is chemistry. So here are the goals. They're going to define chemistry. They're going to talk about, these are actually all of the Unit 0 goals because there's only 1 or 2 goals per section. We put them all together. So at first they're going to define chemistry and look and see how it is around them. Then they're going to understand the role and responsibilities of when working with a group. They're going to learn about community, look at safety guidelines, become familiar with ChemCom, and then understand characteristics. And then figure out, and this is hard for students, so they're going to look at how do they learn. And when you're trying to learn, when students are going to think about, I learn best in this situation, this is what I need to do to be able to learn. And I don't think many students have thought about that in the past. So here's one of the concept checks. Why did you take in chemistry? Could be we have to, but try to push you could push your students a little harder. What else could do that? And where's chemistry in your daily life? And then how would you define it? And then this is one of the first activities they're going to do, and I think it's really cool. They have all these different images, and I've done this with students, with adults, and I get such amazing answers. You give them a couple of pictures. I took them off of the CD and printed them out, and even some of them I found some pictures similar, and I just gave these to a group and said, where do you see chemistry? So you get answers all over the place. Like, if you give a group 4 pictures, they might individually look at each picture and say, well, I see in the fabric bolt up there, I see there's dyes, and that's chemistry, and there's water that has to go in, and there's a chemical process. And then you get groups that look at all 4, and they define the chemistry that's happening in all 4 and the chemistry that connects all of them. And it's just really, really cool, and it's an activity that students and adults both enjoy. So in 2 is why do we study, section 2 is why we study chemistry. And then they look at some different questions. One of them making decisions, or that's still in this first section, and they have to talk with their family members or friends that aren't enrolled in chemistry and see what their thoughts are. Then we have living within the community. One of the activities that they're going to do is a talk, where they're not allowed to talk, but they go ahead and they write things, and you guide them with a question like, what is community, or what is, how does your community affect the way you learn, or different things like that, and then the students brainstorm and they actually respond to each other, but they can't talk. So like here is the chemquandary, so here is community. So they think about what are different types of communities, and how do different types of communities affect you as well. Okay, and then we do the lab rules. They're going to go through, and one of the things that I think is really cool is we give them the lab safety rules, and they have to talk about, give me a rule in your everyday lives that actually is similar to that safety rule. So like the first safety rule, finding a problem. So in most states, inexperienced drivers have to have a licensed adult driver. The first rule talks about you need to have a teacher in the room when you do chemistry. So they're going to do a similar rule, applies to every life for the first 10, and then they're going to talk about in the second 9 what are the consequences if they don't follow these rules. So they're actually looking at the safety rules and then putting them in other words and analyzing them, which I think is very, very useful. So here's just a copy of the rules. Then in section C, they're going to also do their very first lab. It's a lab on density, so many of them may have done that, but if you want to review density with them, you have that as well. Okay, and finally section D is how is ChemCom designed to help you learn. So then they talk about why is it important, what is the purpose, and what are 3 activities that help you learn. talk about the sandwich style of ChemCom. So you have what the bread is, the meat and the cheese are all of these activities, developing skills, investigating matter, modeling matter, making decisions. And then you have the condiments, the goals, the concept checks, chemistry at work, chem quandary. And then so they think about how that is actually structured. And then you get the students in groups, and they're actually going to walk through each of the 7 units. Each group is going to look at a different unit, and they're going to pull out some of the things, like what is the challenge in the unit? Tell us where one developing skills is. And then finally, they're putting it all together is to write a letter to themselves, talking about what is success, what do they need to do in order to be successful, and then how will you know if you're successful. And a lot of teachers collect that, and then they seal it, and then the student actually reads that at the end of the course as well. So again, in review, the things that we always want to make sure are part of ChemCom and are definitely part of the 6th edition is decision-making focused. We're always going to have how does chemistry apply to your real world. I think that's extremely important. And some really cool things, what are the limitations of science and technology? Students need to realize that we don't know everything, and that we're trying to understand things. Looking at the different pieces, the particulate, the symbolic and the macro nature of matter, and then making sure lab activities actually depend on what they're doing. We want to make sure that this is accessible and it's meaningful for all first-year students in chemistry. So it's very important to all students' part. This is meant for all students. So again, we've maintained the ChemCom philosophy. We've had this new unit. The first 4 units are actually in a different order if you're familiar with previous editions. So in the past we went water, materials, petroleum, and air. And now we're going materials, air, petroleum, and water. And one of the most exciting things I've ever heard from teachers is, and I think almost every single teacher I've talked to that's used the 6th edition, they're like, my students never understood water when they did their town hall meeting when water was number 1. But when water moved to section 4, or to unit 4, they had the most dynamic, science-packed, science information-packed presentations that they'd ever had in their entire teaching career. And one teacher has been teaching 35 years and using ChemCom the entire time, and she said, though the 6th edition, the water presentations were the best she's ever had because the students actually understood the science. So we strategically reorganize them so students learn content in a way that will make them more successful. The concept checks and goals are added. The students actually in section 2 in unit 2 are learning a lot about science practices. We talk to them what makes a good scientific question, what doesn't make a good scientific question, and pieces like that. That whole entire unit, along with teaching air and all the gas laws and a lot of different things, those are the important, like we really focused on letting them learn about the process of inquiry. There's new investigations, and every investigation has a different format, but to focus on what students are actually doing. These ancillaries have been released. I apologize for that. And then we're continuing to do professional development and webinars as well. I want to thank our writing team and our editorial advisory board, who Steve has been so generous to give us of his time this evening, all of our pilot testers. I want to thank all of you. And I've seen 2 questions fly by as I've been talking. So if you have, actually I see 3. If you have more questions, I'm going to go through those. Let me go back to this last slide. If you ever have any questions, our ACS website, acs.org/ChemCom, the publisher's website, they have some really cool things on there. Emails are here as well. That is an M_MURY. Let me go through these questions. So, and Steve, please chime in. So I have, are there any chapters that are more integral than others, or should the units be done in sequence as the book presents them? So that's a great question. The first 4 units, so units 1, 2, 3, and 4 are written so that they are taught sequentially because the chemistry builds on each other, on itself. So if you were to teach like Unit 2 before Unit 1, there would be some things that the students are missing. So we highly, highly recommend that you teach Units 1, 2, 3, and 4 in order. 5, 6, and 7 are pretty standalone. So once you've done what we call the core 4, those first 4 units, you can teach 5 or 6 or 7 or mix them. I know some teachers teach part of 6, part of 7, part of 5 so that they can get through, that they can look at those. They ask their students, what are you interested in? Because we have Unit 5 is on industry, and so there's a part on nitrogen chemistry and fertilizers, but there's also a part on batteries, and they talk about their cell phone batteries and all of those types of things, so students have an interest in that. That whole thing is brand new to this edition. Unit 6 is nuclear, and it revisits a lot of atomic theory. So if you have atomic theory in your standards, that's a good place to go. Unit 7, probably the least used. Unit 5 and 7 are least used than 6, but Unit 7 is a lot of biochemistry, a lot of health pieces. So a lot of teachers may not use that because they see that their students may be receiving that in health or in biology. We actually have some health teachers that use that unit as their health unit or use that in their health classes. But those are meant to be pretty standalone as well. So hopefully that answers your question, Michelle. Did you have anything to add to that, Steve?
You did a great job, Michael.
So let me see. Okay, I'm going to pass this to Steve. I'll tell you a little bit of what my experience with talking to teachers, but it says the text has 7 units. Realistically, how many of those units can you get through? Most teachers get through the first 4 and parts of another one. That is what we have found. We do have some teachers that get through the entire book. That's impressive to me, but most teachers get through 4 to 5, I would say. I'll let Steve comment on that as well.
You're right on that, Michael. You really do need to cover the core 4 of those first 4 units in sequence, as Michael said a moment ago. And then you need to look at your district and state standards to see what other content and curriculum do you need to cover. The industry unit includes Le Chatelier's principle and equilibrium. So if that's included, then you'll either have to pull that in or you'll need to teach parts of that unit. We've got the nuclear unit, and I think that most of our state standards require some type of nuclear chemistry or something in that range. I know my standards in Arkansas, which are quite extensive, also require some biochemistry parts. So to do 5 or 6 is probably, you're looking at, that would probably be a pretty good curriculum. And honestly, I go through the core 4. I teach quite a bit of the industry unit, and I pull in almost all of the nuclear unit, and then maybe 1 or 2 activities out of that last unit on foods as time permits. But you certainly need to look at what your standards are and what fits your school and your needs.
Great, thank you, Steve. The other question from Sherry, if you want to be in contact with me, I can definitely help you with that. We may be able to provide one of our teacher leaders to help you. They're looking at switching their curriculum over to the 6th edition next year for all of their sections, Steve. So they want to revise their curriculum. I can say that I hope you have the teacher's edition. If you don't, let me know, because that is extremely useful, because all the planning guides and everything are in there. The other thing that Sherry asks is, what suggestions do you have for ways to utilize this program with students who have special needs?
The special needs, I think the hands-on activities that are embedded within the unit are a very strong part. Whether you have ESOL learners or you have other types of special needs students, the hands-on activities are important. You'll find that a lot of the activities in the textbook are designed so that they can be shared, so that students would work in small groups or teams. We find again that when students work in collaborative teams, that is often a good teaching technique, particularly for students who have special needs, whether it's language, physical, mental, or whatever type that might be, that those are strong suits with that. There are some amount of ancillaries. There are some, the website for the textbook has animations and some other types of things, and Michael can probably go into a little bit more detail on that, but there are some things there that would help students with visual types of matter as well and stuff there.
Yeah, I think so, and the reading guides that we have are very useful, that are in the Teacher's Resource Finder, and a lot of the activities in the Teacher's Resource Finder are very useful for students with special needs. I think one of the nice things that is done in the Teacher's Edition this time, as Steve has pointed out, is pointing out learning for all and giving you differentiation for each of the, for many of the activities, and even with that throughout the textbook, having those differentiation pieces are extremely important. So that is a great question.
One of the things that we forget to mention is that we often talk about special needs learners, and we tend to think of those who need additional assistance to meet the content. The other end of the spectrum is equally true, and that we have special needs students in our classes who excel and need to go beyond. And I think that you'll find at the end of each section there are some questions and projects and ideas which will allow students to expand beyond the content that you would expect your typical student to be able to complete. So I think you'll see both materials to support students who need additional help on the lower end as well as on the higher end.
Great. And thank you for your comment, Sherry, about the animations. I think the animations are great on the website. So any of you that have not been able to see those, I highly recommend that you see those. They're at whfreeman.com/ChemCom6e, or they actually have them at ChemCom 5e as well. They've been re-rendered a little bit for the 6th edition, but I think they're very useful for the class. And thank you for mentioning that, Steve.
Michael, the other resource I would plug is the middle school chemistry resources. There are some excellent animations and some materials there that can be used to scaffold learning for some students who might have difficulty. And while that's not tied to the ChemCom textbook, I think that those are some rich resources that ACS has provided. And I know that in my state of Arkansas, I put out on our state science listserv that these resources were out there about a year ago, and had comments from several teachers that says, oh my goodness, I'll use these in my high school classes as well.
Oh, I totally agree. I just put up both of those websites, the middleschoolchemistry.com, and then there's for activities that can be pretty much all the way from 3rd grade all the way to high school, the inquiryinaction.org. So, but there's great animations on both of those. They have done an amazing job with those, and those are both totally free. Everything that's a part of those is free for your use. So I would definitely recommend that you try that out. And Sherry, contact me and I will put you in contact with the publisher to get you some more TEs for your students. I mean, for your other fellow teachers. And if you want one of us to come and talk to all of your teachers, we would be happy to do that as well. So I just wanted to let you know that. And Michelle, I see your comment about you're using active chemistry, there are several similarities between ChemCom and the active chemistry. A lot of the types of activities and things are pretty, the focus, I think, is similar between the two textbooks. Did anybody else have any other questions for Steve or myself? Ebooks, yes, the 6th edition is in an ebook form. You can definitely get the ebook, and it's actually done really well. I have looked through it. The ebook, you can go through it, and it actually has like links to the animations to go along with the chapter. So it's actually it's very useful. I think I really like the ebook. Great questions. Thank you, Michelle. I think that's one of Michelle said I like the emphasis on literacy, and I think that is one of the key pieces that we tried to incorporate in this textbook, and we really want students to read and actually make the reading useful and interesting to them. I know we can all probably remember being in classrooms where you were assigned reading, and most of the students didn't do the reading, but we've tried to make the reading in an accessible way for students and for teachers. And then all the sections that have heavy reading, which is more than 1.5 pages, we have made sure to incorporate a reading guide with that, so that gives questions, so students are working on questions. And they're not the types of questions that they can just go and look in the textbook and put the answer in there. There are a lot of the questions that you need to synthesize the information and put them in like a, I'm losing my, I can't remember the, Steve, help me. Like
I'm not sure
Venn
where you're
diagrams
going.
and things like that. So trying to put them in those types of.
Well, they include some anticipation reading guides. There's some
Yeah.
things that do a compare and contrast of their reading. They're not going to be fill-in-the-blank type questions. Instead, what
Right.
you're going to see is, this is what I believe before I read it. This is what I now understand after I read it. Those kinds of things. And they're research-based, and they're designed to really help students engage with the reading.
Okay, here's another question, Steve, from Michelle. When students are performing an investigation at the lab station, since the activities are embedded in the text, do you expect that the students have their textbooks at the lab desk with any materials? Any issues with that? So from my end, one of the things that we did is in the teacher's resource binder, we have actually made handouts of every single one of the experiments, so students do not bring the textbooks into the lab, that they actually bring their handout with them. Other thoughts on that, Steve?
I think you'll find most teachers do that. They don't want the textbooks in the lab area for fear of spilling something on them or getting them wet. So, we'll print them off and either laminate them or put them into a page protector, so that way that you could use the same set of instructions all day long with a set of students, and all they need is to be able to then complete their own data tables or gather their information as needed. And so I think you have to kind of adapt that, but I think you'll find most teachers do some variation of running the lab off on their own beforehand.
And another thing I'll point out is we've actually created data tables for each of the labs, but they're separate from the actual lab handout. So in some cases, as a teacher, you may want your students to create their own lab data table. In some cases, you may want to help them, and that's another way you can differentiate as well. You may have some students that you want to push them to create their own data tables, and some that need a little more guidance. So we have a data table that we have prepared that's at the end of each of those lab sections, so that you don't have to worry about whether you have to give that to everybody, because in some of the labs it does tell the students they're going to have to create their own. The modeling matter activities, all of those there's actually a handout to go along with those as well. So we have created handouts for all of the investigating matters and all of the modeling matters. And the majority of developing skills, there is an additional problems worksheet to go along with that. So students, there's a couple of questions for developing skills, but sometimes some students need more. Sometimes they don't. We don't recommend that you give every student every single one of those additional worksheets. But in a case where your class may be struggling with balancing or maybe struggling with molecular mass, we have worksheets there for those students. So do we have any other questions? Great, Michelle. So if you need any more information from me, please let me know. Send me an email online, so offline, and Michelle asked if there's any other way to see the other resources. I will get you in contact with your sales rep at WH Freeman, and they will be happy to send you that. And I'm happy to provide as much support as you need. If your entire district switches over, we will be happy to provide individualized professional development where we'll be able to come to your district and help you with help your teachers with the textbook. And I know that the sales reps will be able to send you some of the resources to look at. Okay, so I don't see any other questions. I want to thank all of you for your participation tonight. You guys have been great. You had awesome questions.
This is one of the better webinars that I've been on, Michael. I appreciate the fact that the attendees were so interactive and had so many good questions, and it really made it a lot more engaging for all of us, I believe.
Yes, it was awesome. So thank you all. I hope you have a wonderful evening. I want to thank you again, Steve, for all of your wonderful input and your help, and I really appreciate that. And please let me know if you have any questions. I will be in contact with you in a couple of days to send you a documentation that you participated in the webinar. But if you have any questions, don't hesitate to contact me, and I will get you an answer as soon as possible.
And feel free to contact me as well if there's any way that I can be of resource or help.
And I'll also have this recorded, and I'll send you the link for the recording in case you want any of your colleagues to listen to this webinar. They can view it at any time as well. So once again, thank you so much. Thank you again, Steve, and I wish everybody a wonderful, wonderful evening.